Hi, this video lecture, we are going to see about the addressing modes. So when I say addressing mode, this is nothing but the way in which the operand is actually specified in an instruction. So how we have specified the operand in an instruction, that is what we say it as addressing modes. So we can also say addressing mode as which is a rule for interpreting or modifying the address field of the instruction before the operand is actually used. So when I say in which way the operand is going to be specified in the instruction, there are so many ways. These are all some of the different addressing modes available. First one is implied addressing mode. So here from the term itself, we can understand implied. It means the operand is specified implicitly. Instead of giving it directly, it is specified implicitly in the instruction. So example for this type of instruction, let me give you an example. CMA, that is complement accumulator. We have not specified any address or any register. Nothing is there. Simply CMA means you are going to complement the accumulator. Okay. And similarly, when it comes to any stack operation like add, push, something like this, any zero address instruction, all that comes into the category implied addressing modes because we are not going to specify the operand explicitly. Then the next addressing mode is stack addressing mode. So here, let us see an example, add. So here we are not going to specify any operand explicitly. So when I say add, so this instruction will pop out the two operands on the top of the stack and it will perform the addition, and after performing the addition it will be placed or it will be pushed again to the top of the stack. So whatever operation you perform, so it will be taking the data from the stack and it will be storing the results back on the top of the stack. So this is stack addressing mode. Then the third one is immediate addressing. So here the operand is specified explicitly. So in the instruction itself, we are going to give the value instead of using a register or instead of using an address. Directly you are going to give the data or value. So that is immediate addressing mode. You can look at the example here, add 100. So this means that 100 will be added to the data available in the accumulator. Similarly, move R, 20. So this constant value 20 will be moved to the register R. So this is immediate addressing. The next one is direct addressing mode. So here the effective address of the operand will be directly given in the instruction. So you can see the diagram here. So here A is the effective address of the operand. So this A is the location where you can find the data. Directly, we are giving the location of the data in the instruction. So when I say add X, so this X will be added to the accumulator. The next one is indirect addressing. See, you can look at the diagram here. So here in the instruction, we will give the address where you can calculate the effective address of the operand. So you can look at the diagram here. So the effective address of the operand is stored in the location A. This A will be specified in the instruction. So A will point out to the effective address or the memory location where your operand will be. So this is indirect. We are not directly giving the address of the operand. Say, for example, your data is available in the address 200. So in the instruction, you will not give opcode 200. Instead, you will give the effective address of the operand, which in turn will be referring to it. Okay. So that is why it is referred as indirect addressing. Then the next one is register direct addressing. So here the data will be available in the registers, and the address field of the instruction will be referring to the CPU register that contains the operand. So here no references to the memory is actually required. So it is direct. We are not going to refer to any memory. So you can see here. So here the register set is having the data, and that particular register number is specified in the instruction. So when I say add R, it is going to add the content of R with the accumulator. Then the last is register indirect. Similarly, how you have an indirect addressing. So here the data will be available in the memory, and in the instruction you are going to specify the register set. The register set in turn will have the effective address of the operand. So here you are going to have memory references. Okay. So from the instruction, you will move on to the register set, and in the register set, you will be having the address of your data. So this is register indirect addressing. Thank you.